Now let's start some real stuff. Now let's look at a beam in equilibrium. Now we have two conditions for a beam in equilibrium. The first condition is this, that the sum of the forces acting vertically upwards must equal the sum of the forces acting vertically downwards. As you can see on this beam, we have three forces acting on the beam. We have the force acting upwards here. We have F1 and F2 acting downwards. Now, this condition is saying that the sum of the forces acting upwards must equal the sum of the forces acting downwards. Now, can anyone tell me which of the forces is acting upwards? So we have a force RP. So we have RP is acting upwards. Is RP equal to the forces acting downwards, which is F1 plus F2. Is F1 plus F2. So this is the first condition for beams in equilibrium. It says that the sum of the forces acting vertically upwards must equal the sum of the forces acting vertically downwards. Let's look at the second condition. It says that the total moment of the forces acting on a beam must be zero. Now, for this total moment to be zero, it means that the sum of the clockwise moment must be equal to the sum of the anti-clockwise moment. I'm saying that for the total moment to be zero, it means that the sum of the clockwise moment must be equal to the sum of the anti-clockwise moments. Alright, now this is known as the principle of moments. This concept is known as the principle of moments, which states that the sum of the clockwise moment must be equal to the sum of the anti-clockwise moment. Now, I will give us some steps of how we can apply this condition to questions. I'll give us at least 4 steps. Now, the steps are as follows. Step 1 is that we choose a moment point. We choose a moment point, or we can call it the pivot point. Pivot point. So step 1, we choose a pivot point. Step 2, we identify the clockwise and anti-clockwise moments. All right, very important. Then step 3 is we equate the clockwise moments to the anti-clockwise moments. That is step 3. Then step 4, we can now evaluate. We can evaluate to find the unknown. So guys, these are the steps that we can use to solve for moments using the second condition. These are very, very important. I want you guys to listen very closely These are the steps that we use to find the second conditions. Step 1, you choose a pivot point. Step 2, you identify the clockwise and anti-clockwise moments. Step 3, you equate the clockwise moment to the anti-clockwise moment. Step 4, you evaluate to find the unknown. I will show us now how to apply these steps in this question. Now, step 1, you choose a moment. Now, moments are chosen at any point where you have a force. That means from this diagram, I can choose my moments at F1, at point P, and at F2. So moment points are chosen at any point where you have a force. Point 1. Point 2. Any point where you choose your moment, that point, the forces acting at that point becomes 0. I repeat that. Any point where you choose your moment, the forces acting at that point becomes 0. So let me choose a moment. Let me choose point P as my moment. Alright? So I can say taking moment at point P. Alright? If I take my moment at point P, it means that RP is what? Is 0. Because I was saying that the points acting at that, or the forces acting at that point becomes 0. So if my moment is at point P, it means that this force becomes what? 0. So I am left with F1 and F2. This force is 0, so I don't use this force. I'm left with just two forces now, which is F1 and F2. So step 2 is that we identify the clockwise and anti-clockwise moments. Now I want us to note that if P is my pivot point, it means that F2 we turn towards the pivot, F1 we turn towards the pivot. Look at this, guys. Look at this very closely. If point P is my pivot point, the other forces we tend to turn towards that pivot point. Now, so I will use my step 3. What is step 3? Equate the clockwise moment to the anti-clockwise moment. Okay. Good. Nice job. What next? Now, what is clockwise moment? What is moment? Is the force times the distance from the force to the pivot. I repeat that. Moment is the force times the distance from the force to the pivot point. F2 times distance from F2 to the pivot is B. So it will be what? F2 times B. So it's F2 times B. That's my clockwise moment. So for my anti-clockwise, it will be what? F1 from F1 times what? Times the distance from F1 to the pivot, which is what? A. So F1 times A. So this is how we solve questions on beams in equilibrium. Now, I want us to note something very important, that the first condition, which is this, the first condition is used to solve for forces alone, while the second condition can be used to solve for a force and for the distance.